Hello, thank you for choosing this video. I'm Professor G, and today what we want to do is create an exponential regression. We're going to be using StatCrunch to do that today. We're going to be using some real data from the Ebola virus outbreak that happened in 2014. And this is data collected by the World Health Organization. And as you can see, Guyana did a very good job of controlling the spread of the virus. It had a slow sort of rise, and it was the earliest one to taper off. But Liberia and Sierra Leone did not do as well. What happens is a very slow growth and then this sharp rise for quite a while before, I'm guessing, the international community sort of got really involved, and there were some advances made that caused these inflection points that caused them then to bend and turn down, right? And so what we're going to focus on is the total number of cases in Liberia and the total cases in Sierra Leone to create an exponential graph. Now, all of this was in an Excel spreadsheet, so I actually downloaded the spreadsheet. But what I did was I had to add weeks since the March 31st date, and then I just sort of counted them all up. And what I tried to do was keep pretty close to the Monday dates. There are a couple of Wednesdays and a couple of Sundays in here, but mostly these are all Mondays. So this is the approximate number of weeks since they started tracking the outbreak. All right, and this is the total number of cases in Liberia during that time frame and the total number of cases in Sierra Leone. And you can see that you have this exponential growth, this very curved growth that happens in that time period. Okay. Now what happens after this time period is it starts to slow down, and the exponential model does not very good fit. And so what we're going to do is we're going to restrict our to this, our look at the data to this. Okay, so we've got, I don't know, 9 months worth of data here to look at. All right, so I am going to import this into StatCrunch. All right, so let me go ahead and do that. Oh, I'm going to save it. All right, and here is my StatCrunch. What I'm going to do is, with that file that I've already sort of cleaned up, that doesn't have the Guyana in it, that doesn't have the deaths and things in it, that has the number of weeks added in, that cleaned up file, I'm going to choose it and open it. Alright. And so this is all looking good, so I'm going to scroll down to the bottom and load the file down here in the bottom. You can see it. So here comes my StatCrunch. Alright. So here it is. Here's the actual date. Here are the number of weeks since we started looking at the cases. Here's Liberia, and here is Sierra Leone. Okay, so what I'm going to do is I want to make a scatter plot of Liberia and show you what it looks like. So let's graph a scatter plot of Liberia, and on the X is going to be the weeks since, and on the Y are going to be the number of total cases in Liberia. I'm going to go ahead and compute that. And you can see, there it is. There is my flat sort of growth, and then that super big jump that we saw to over 7,000 cases. Okay. Now the problem with this is, okay, in StatCrunch, to model this, we wouldn't want to use a linear regression. Okay. So if I go to Stat and I go to Regression and I do a simple linear regression and I select the week since, and I select Liberia, and I go ahead and compute that. It's down here at the bottom off the screen. I'm sorry. Here it is. Okay, and so the R squared the R value is about 0.87, not too bad. The R squared value is about 0.76. You might think, oh, that's a pretty good fit. Okay, but when you look over here, the data is above on the ends and below in the middle, and this tells you that a line is just a terrible way to predict this. We want to do better with that. So I want you to remember that the correlation coefficient was 0.87 and our R squared was 0.76. All right. Now, I'm gonna kind of pull. Oh, I don't know what I'm gonna do with this. I haven't actually tried to do this before. All right. So what I'm gonna do is I'm gonna close this out. Okay. And so now what I need to do to make it better is I need to convert the data in Liberia so that it is actually straight, so that I can use an exponential regression. So I gotta convert the Liberia data. So what does that mean? Well, let me pull up this little thing right here, right? So a little background, okay? What we're getting ready to do is to perform an operation to convert our set of data values, okay, for Liberia into a different set of values, ones that are actually going to be linear. And then after we get our linear regression, we're going to perform the inverse operation to recover the original values to actually get our exponential function. All right. Now, I know this seems weird, but to understand, I'm going to use some operations we're very familiar with and then go to one we are less familiar with in math. It's the exponential and the logarithm. Okay, so if I take 3, right, and I add 2, I obtain a new number 5, right? I've sort of converted 3 into 5 by adding 2. All right, so 3 plus 2 is 5. We all know that. To get the 3 back, I have to perform the inverse operation. In this case, the inverse of addition is subtract. So 5 minus 2 is equal to 3. Okay? So the idea is the inverse operation recovers the original values. This works with multiplication as well. If I do 3 times 2, I get 6. And if I want to get the 3 back, with its inverse being division, I take 6 divided by 2, and I get my 3 back. I multiplied by 2, so now I need to divide by 2. All right? And of course, with exponents and roots, this still works. If I take 3 and I square it, I get 9. The inverse operation of an exponent is a root. And then the square root of 9 is going to give me back my 3. All right, so those inverse operations are going to really help us out. So now we don't have a linear scatter plot. It's actually an exponential, which I showed you. So what I need to do is to convert the data so that it's linear and then convert it back to its linear form. Okay? From its linear form to its exponential form. Sorry about that. To do this, we need the following functions. To get rid of the exponential nature of the graph, I'm going to use the natural logarithm, or logarithm naturel. That's what the ln stands for. And then to get it back to its exponential form, I'm going to use the e, the special letter e, or the exponential. Okay? And these functions are inverses, just like addition and subtraction are, just like multiplication and division are, and just like the exponent and the radical are. To illustrate that, the ln of 3 is 1.099, and then when you actually use the exponential of 1.099 is 3. You get it right back, that 3 that we've been looking at all along. All right? So what I'm going to do in this problem is I need to convert Liberia using the logarithm to straighten it out. So what I'm going to do is I'm going to go over here to var 5. I'm going to hit data, and I'm going to compute an expression. And the expression that I'm going to compute is I'm going to go down to the L's, and there's my ln. I'm going to add that function, and then I'm concerned about Liberia, so I'm going to click that and add that column. So I'm going to take the ln of Liberia, and I click OK, and I click compute. And so what's happened now is I now have the natural log of all of these numbers in this particular column. And you're like, Professor G, why did you do that? What happened there? Well, now when I take the graph, all right, and I make a scatter plot of the weeks, and now instead of using Liberia, but the ln of Liberia, and I compute it, I actually get a much straighter form of the data, okay? Now, I know it still looks kind of wiggly because it's data, and data is messy. But here's what we're going to do. Now, I can actually go ahead and do my linear regression on the weeks and the natural log of Liberia. And when I compute it, you'll notice my correlation coefficient is now 0.97, right? And my R squared is up to basically 95. Okay? Remember before it was only like 75. So it's gotten a lot better. How much better? Look at how well the data fits the line. But this is the more important point. Here at the end and in the second half is data above, and here at the ends is the data below. So the data is above and below in several places, and so this is a much better model, a much better fit. Okay? And so what we have here is our, I'm going to pull this down just a little bit further. We don't need all that white space in the video. What I have is my intercept and my slope. And you'll notice that the intercept is the A value and the slope is the B value. So what I'm going to do now is I basically have taken the natural log of the data. So to convert it back, I'm going to need to take the exponential of that linear function. Okay? And so what I'm going to do is in var 6, I'm going to go data, I'm going to go compute, I'm going to compute an expression, and the expression that I'm going to compute is I'm going to go down to the exp and add that function, and the value that I'm going to put in, hopefully you can see this, is this 1.5261. Alright, so it's got 1.5261. Alright, and I click OK, and I click compute, and there it is. This is my initial value. Remember, this is my initial value for my linear regression. So this is now the initial value for my exponential regression. Okay? And so now what do I want to do? Now what I want to do is do the var 7, and I'm going to hit data and compute the expression, and instead of doing the exponent of the 1.526, what I'm going to do is the 0.2271 and click compute, and there it is. And then this is my rate of growth, right? This is my rate of change for my linear regression. So now this up here, this is my growth factor. So it's 1.2549. So basically it's a 25% increase in cases in Liberia each week. 25% more cases. And so as you notice, it grows very slowly in the beginning, but then all of a sudden it sort of takes off, and we go from 12 cases at week 8 to over 7,000 cases in week 35. And so this is why it looks a little weird, because it grew very slowly in the beginning, but at the end it grew a whole lot faster. All right? So this is it. Now you're wondering, does this do a pretty good job of making the data? All right? Well, this is a great question. Hey, does this actually do a good prediction? So what I'm going to do is to show you how well these two numbers work is I'm going to go to var 8, and I am going to compute an expression. All right? And here's the expression I'm going to compute. I'm going to build. Now remember, I have my initial value of 4.6002. And to that, I'm going to multiply by 1.2550, just rounding to 4 decimal places. And I'm going to raise that to, and I need the column weeks since. And so this is my exponential regression with my initial value of about 5 cases, my growth of about 25% each week since I started collecting the data. And I'm going to click OK and compute it. And so now I've got these cases over here as it's going up, right? And here is the actual. So here's my predicted, and here's my actual. So how does it look? Well, let's go ahead and graph a multiple plot. And for my x variable, let's go ahead and do week since. And let's go ahead and do the Liberia. I'm going to add it. And I'm going to do week since and the predicted, right, my exponential regression, and add it. And take a look and see what it looks like. And you can see in the early stages, the blue and the red are very close together, right? The blue is above, the regression is an underestimate, and then it starts to trail off, right? The actual number of cases starts to slow down, and so then my exponential regression becomes an over estimate because something changed, right? And so I went a little bit too far out. But look at how nicely that fits to the data for most of the graph. All right, and so this is how you can actually get an exponential regression. There it is. Let me make it a little bit bigger. All right, there's your exponential regression using StatCrunch and some real data. Okay, again, I did clean the data up a little bit so that we wouldn't have things that distracted us from what we were doing. But this is our video. I hope you found it really helpful. What you might want to do is try and do it with Sierra Leone and see if you can get the exponential for that. I'm going to pause it. I'm going to actually do it, and then I'm going to show it to you so that you can check your answer. All right? So what are we going to do right now? I want you to see if you can calculate the exponential regression for Sierra Leone, and then I'm going to show you the answer. Okay, so hopefully you've already done this, and now I'm going to show you how to do it real quick, right? So var6, data, compute the expression. Remember, it's the ln, but not of Liberia. I actually need to use Sierra Leone. Oops, that didn't work. Sierra Leone, add column, and close it up. Hit OK, and compute. So there's Sierra Leone, all right? And so now what I can do is do a stat regression simple linear, week since, the ln of Sierra Leone, compute. Uh-oh. Oh. Oops, I have these zeros in here, and so I got a bad error. I'm wondering if you guys did that. If you did, I'm very sorry. Okay, so what we want to do is delete those rows. So I'm going to go to data. I'm going to go to row. Oh wait, let's see. Over here, edit, rows, delete, and go ahead and delete that one. So let's see. 1, 2, 3, 4, 5 need to be deleted. So edit, rows, delete, compute, and there it is. Okay. So now we've got something nicer that we can actually compute. Sorry about that. So stat regression, simple linear, week since, the ln, compute. Aha, this looks a lot better. We've got our 0.91 and 0.83 for our R squared. So it should be fairly nice to the line. It's interesting that so much of it is above and then very little bit of it is below, but apparently that is the line of best fit for this. And so now I've got the 1.7312 that I need to take the exponential of. So now I'm going to have data, compute the exponential of the 1.7312, and then I'm going to compute the exponential of the rate of change, which is 0.2198, rounded to 4 decimal places. And so I'm going to compute that. Alright, and so I've got that for my exponential function. And so now, of course, I can go ahead and compute the expression of 5.6474 times 1.2458. So this growth is a little bit slower, raised to the and now what I'd like to do is raise it to the week cents and compute, and there it is, my data. And so now I can look at the graph of the multiplot where X is week cents and Y is Sierra Leone, and X is week cents and Y is my exponential regression, and I can look and see at how well those fit. And again, the blue is a little above and the exponential is a little bit of an under prediction at the beginning, but it follows it pretty well until we get to right about here where the data starts to slow down and become more linear. And so now I've got an overestimate at the end, and this is why extrapolation is so dangerous. But for Sierra Leone, what you should have gotten for the exponential regression is this initial value, this growth factor for the weeks since. Alright, so that's going to conclude this very long video about how to use StatCrunch to make an exponential regression out of some real data. I hope you enjoyed it, and if you did, that makes me happy.